Hi, I'm Cheryl Leach. In this problem, we're going to be looking at an application from economics called the point of diminishing returns. Well, exactly what is the point of diminishing returns? Well, if you think about owning a business and you want to invest money, say in advertising of your product, well, you would expect that the more money you invest in advertising, the more your revenue will increase. And indeed, that's what typically happens. So the more advertising dollars you put in, your revenue will go up. Well, there typically is a point where when you put more advertising dollars into your product, your revenue still may increase, but that rate of increase begins to diminish. And we call that point the point of diminishing returns. Graphically, it's going to happen right at that inflection point. So my revenue is still increasing, but not by as much as it was initially. So this is the point of diminishing returns. Now, why is that important? Well, it's typically felt that putting more money in past that point of diminishing returns is not a wise use of your capital. You could spend that money more wisely someplace else. So we'd like to find where that point of diminishing returns is for my example. So I'm given a revenue function. Because I understand now that the point of diminishing returns happens at the inflection point, I need to find the inflection point, which means I need the second derivative. So let's go ahead and look at dr dx. Now this is a fairly large function. However, at its root, it is a constant multiple. So I'm just going to pull that 1 over 50,000 out and take the derivative of what's inside my parentheses. So that will be 1200x minus 3x squared. Okay. Well, that's great, but that's only the first derivative. I want the second. So I'll take the derivative again. Again, the 1 over 50,000 is a constant multiple that will be pulled out. And the derivative of what's inside my parentheses is 1200 minus 6x. All right, now what do we do with this second derivative? We want to know when it's 0 and when it's undefined. Right? Well, this particular derivative will never be undefined, but it will equal 0. It's going to equal 0 when what's inside those parentheses is equal to 0. So let's set 1200 minus 6x equal to 0 and solve for x. So I have 1200 equals 6x and x equals 200. So something is changing at 200, or maybe I should say possibly changing at 200. So let's use our chart to see exactly what's going on. First, I need to set up my interval. Well, the first thing I should notice is that I was given an interval to look at. X is going to be between 0 and 400. Now, one other thing I should point out here is in the problem in your book, it will state that X is being measured in thousands of dollars. So we're going from 0 to $400,000. But I'm just going to mark this for right now as going from 0 to 200, because that's where my break is, and then 200 to 400. Now we need a test point on this interval. So pick any point you like from 0 to 200. Let's just try x equals 1. And we're going to plug that into the second derivative. Well, if x equals 1, the piece that's in parentheses is definitely a positive number. I'll multiply it by 1 over 50,000. It's still positive. My conclusion? The graph is concave up. Now let's look at our second interval. Pick anything you like between 200 and 400. Okay. Let's just try 300. Okay. If I plug 300 into my second derivative, 6 times 300 is 1,800. 1,200 minus 1,800 is a negative number. When I multiply that by 1 over 50,000, still a negative number. Okay. And when the second derivative is negative, I know my function is concave down. Okay. Now I have a change from concave up to concave down, which is exactly what I wanted when I look at my picture for my point of diminishing returns. So x, the x coordinate of my inflection point, is 200. Now let's make sure that I answer the question correctly. How much money should I be investing in my product? Well, X is 200, but remember it's measured in thousands of dollars. So I should be spending $200,000 and no more to get the maximum amount out of my advertising dollar. I hope this helps. Thanks.